Okay, let's start with something that might surprise you. No, really, it reads chunks, little pieces, things called tokens. You can think of it like Lego bricks, common short words, or like one solid brick. But longer, more complex words, they get built from several smaller ones. The model only ever sees the bricks, not the complete word you were thinking of. So, for instance, the word cat is just one token. Simple enough. But a word like don't actually becomes two separate pieces, do and don't. And a big one, like unforgettable, gets split into three. And trust me, that one small detail has way more practical consequences than most people realize. On average, in English, it takes about 1.3 tokens for every single word. So it's not a one-to-one ratio. And that means when people try to estimate cost just by counting words, well, they're already off. And it gets even less efficient for other types of text. If you're working with code or structured data like JSON, you could be using roughly twice the number of tokens as you would for plain English, saying the exact same thing. This whole token thing also explains a really common annoyance. Why can these huge language models write beautiful poetry, but then totally stumble over basic math? It's because the model doesn't see the number 4. It sees the token for 4. These tokenizers just weren't built for math in the first place. And if you don't happen to know what tokenizers are, you're probably going to be like, the system is, well, fundamentally a bit unfair. A sentence in Hindi or Chinese can easily use 4 to 5 times more tokens than the same exact sentence in English. That means the same meaning costs more. And it fills up the AS memory that much faster. It's just the reality of how these models are built today. So, all this talk about filling up memory brings us to the context window. What is it? It's the absolute limit on how much text the model can see. It's the limit on how much text the model can see at any one time. And I mean, everything counts. Your message, its response, any system instructions, the entire conversation history, all of it. The best analogy is to think of it as a desk. It might be a really, really big desk, but it's still just a desk. And once it's full, something's got to go. Now here's a mistake a lot of people make. The context window is working memory, not long-term memory. It's much more like the RAM in your computer than a hard drive. When you start a brand new chat, the model has no idea what you talked about last Tuesday. Whatever was on the desk is just gone. And boy, have these context windows grown fast. I mean, just a few years ago, we were working with 4,000 tokens. Today, the best models out there can handle over 1 million. That sounds like a massive, massive improvement. But yeah, there's a catch. As it turns out, a bigger context window doesn't automatically mean better reasoning. What happens is models pay really close attention to information at the very beginning and at the very end of a long conversation. But everything in the middle just kind of becomes a blur. Researchers actually confirmed this and gave it a name, the lost in the middle problem. So the effective window, the space where the model is actually reasoning well, is often half of the advertised number, or sometimes even less. And it's not like it just suddenly stops working. It's more of a gentle slope. Every single token you add to the conversation makes the model's reasoning just a tiny bit worse. Some people have started calling this context rot. So that lost in the middle thing has a really practical consequence that is absolutely worth remembering. If you really want the model to follow a specific instruction, you have to put it at the very start or the very end of your prompt. Whatever you do, don't bury it in the middle. Think about it like a 50-item grocery list. You're going to remember what's at the top, you'll remember what's at the bottom. Everything else, it's kind of a blur. The model works the exact same way. And what happens when that context window fills up completely? The provider has to make a choice. Some will just give you a hard error message. Great. Others will silently start dropping the oldest messages without telling you. So the AI just starts to forget things, and you have no idea why. And some will try to summarize the old content, which means losing important details. The real problem is you usually have no way of knowing which of these is happening. The fix here is actually really simple. When a conversation just starts to feel awful or the AI is getting confused, just start a new one. Seriously. Don't try to push through a broken session hoping it'll get better. It won't. Okay, finally, let's talk about the hidden costs. The AI providers charge per token, right? But not all tokens are created equal. You have your input, that's what you send in, and your output, what you get back. And they are priced very differently. Here's a good way to think about it. Input is like a chef just reading the order ticket. It's fast, done. But the output, that's the chef actually cooking the meal. One ingredient at a time, it's much, much slower and way more expensive. That output almost always costs more. We're talking 3 to 5 times more. Now, for one simple conversation, it's basically nothing. But if you're building automated workflows with hundreds of tasks a day, all those little fractions of a penny start to multiply really fast. And another thing, longer context is also slower context. Doubling the number of tokens you're working with also doubles the time it takes to get a response. So let's just recap the best practices here. First, keep your prompts and your system instructions lean and focused. Second, always place your most important rules at the very start or the very end of your prompt. And third, don't ever be afraid to just start a fresh conversation when the quality starts to drop. And that's really the foundation of how this all works. Next time, we're going to dive into the fun stuff, randomness and temperature.